Okay, we're looking at improper integrals. And you guys are in AP Stats, a lot of you, right? Do you know the function that represents the bell curve? So just humor me here. And you can go impress Miss Magruder.
We're doing stats.
Right? Yeah. Welcome to math class. Thank you. Okay. There's the, well, it's in your book. Yeah, you know, I just kind of looked at it and guessed. No, yeah, it is. Okay. Now, what you know from your stats knowledge, most of you anyways, that these tails go off into infinity, right? So how can I, but in stats, we calculate area under the bell curve. What's the area under that curve? 1.
Oh my gosh. We're doing Z-scores.
How can, right? How can I have something never touch the axis, okay? It goes on to infinity and negative infinity. Have an area.
Well, rounding.
Okay. I can tell you, yes, but this is what we're working with today. It's counterintuitive, right? It doesn't make sense. You would think the area would be infinite, but it is not. Okay, so I'm going to draw on a different example to show you why it's not, but that's kind of what we're looking at here. Holy cow, right? Okay, so we're going to look at actually e to the negative x. Okay. Just because this one opens a can of worms because it's both sides infinity. So I'm just going to worry about e to the negative x. It's a little more simple to integrate. Okay, so e to the negative x is such. Okay, I believe this is 1.
Isn't that still infinitely the other way?
Yeah, so we're going to infinity here, right? Okay, so we want that area, A. So you're thinking, scratch my head. I'm just going to write me an integral. Write me an integral. What are my limits? Okay. Yeah. Okay. Here's how we deal with those. All right. We have to take that, and for now, we're going to call it R. And then at the end, we're going to take the limit as R approaches infinity. Okay? So we have the integral from 0 to R of e to the negative x. That's doable, right? Because R is just some, it's infinity. It's not a number. So we're going to have to use limits to solve this. So what is that integral? Right? I think you're right. Should I check the book?
Yes.
Where do you get the negative though?
Because it's e to the negative x. If you take the derivative, you have to undo the chain rule. Okay, good. Good. All right, so this would be negative e to the negative r minus negative e to the 0, which is 1, right? We need to now do this. That's how we deal with the infinite. Okay.
Wow. That's beautiful.
Yeah, positive.
Oh, this is?
Yeah.
Yep, because it's above the x-axis. Good. Okay, what does this give us? It might be a little easier if I extend a screen. Okay, that's the one downfall of this program. That messes with those. Okay, it's easier if you do this. Does that make it easier? Because negative exponent means drop it under. So what's that go to? 0. Yep. And that is, the area is 1. But is it hard to deal with? No, it's not. You just recognize, oh, I have an infinite integrand limit. So I have to put r in, and then I take the limit as r approaches infinity at the end.
Here's my question. That's just e to the negative x, where it crosses that 1 and goes down like that. That area is 1.
This
How
is.
is the one above it also 1? Both sides.
It's a great question. Let me know if you figure it out.
It's 1. Shouldn't it be 1 tall?
This is 1 tall. Yeah, I believe it is. Because it's 0 over 2. Yeah, it's 1.
Now
What'd you do that for? I was trying to like gloss by it.
maybe it's just thinner.
Are we doing standard deviation?
Sure. It probably, it reaches the x-axis faster, I would say is probably what it is. Okay. No, we're not getting into all that. That was just me relating your knowledge to 2 classes. Okay. Here's another example. Just
Oh, interdisciplinary learning.
Is that cube? Would it even really science?
okay. You might see something like show that. This is where you're going to see the first of these terms. This integral converges. Okay. These converge and diverge are very big words in calculus. In fact, that's our sequence and series studies. Do they converge or diverge? Converge means you get an answer, a number. They add up to something. Okay. It goes to a value. Diverge means infinite, negative infinite. It goes somewhere that we can't stop it. Okay.
Converge?
Converge means it gives you a number. For now, we'll get a little deeper into it. And diverge means it goes on and doesn't have a boundary. Okay. It's x cubed.
But I thought they didn't really have any answers in the first place. 4? It's 4. Like the last one? 4. Didn't you technically say this goes on forever?
The addition does go on forever, but you at the end, you're adding so many really small numbers that it never pops above a certain value, and that value is 1. Does that make sense? So let's say you have 1, you're getting really close to it, but you're never going to pop over the top. Okay, so again, we'll get into more of that with sequences and series, but that's where we're starting. All right, what's this? Rewrite. Yeah. Add 1. Divide by. So this is going to be 0, right? Yeah. So we have r to the negative 2. Yeah, I think you're right. Positive. So just 1 over negative 2r squared. Okay, where are you lost? Consider this is a number.
Okay.
So just plug r in.
Yeah,
It's been so long since we've formally written out an integral like this, right? Yeah, well, minus the negative. Okay, and now do the limit. Please get used to writing these out, because the AP test, they might give you a free response. Get used to writing it out nice and formal, okay? We want to earn those points. Because they're probably going to want to see this, and they're probably going to want to see this. This is, 0. This goes to 0. Okay?
Got it.
All right, I'm going to skip example 2. I think you're good there. Yeah, pretty much. Yeah, it's another Revenge of the Teens movie, that Divergent is. Okay. Calculate the integral from 0 to infinity x e the negative x. Look familiar?
It looks like the first one. Is this one gonna be divergent?
No.
Okay, first thing first. We changed to R.
Anybody know how to solve this integral? You've got lots of methods now, and you're going to have to deduce which one to use. This is an integration by parts problem.
For real?
Okay. If you think substitution, see how those are the same? You can't use substitution because the derivative doesn't give you the other. All right, so substitution's out, but it is by parts. So u is x, right? And v prime would be e to the negative x.
Oh, I see it.
And so it's going to make it more simple. U prime is v is negative 1 e to the negative x, right? So we have
Or are you supposed to do the integral? Are you supposed to do x plus 1 divided by x? Or how does that work?
what?
I don't know. Well, it looks like you did the derivative and you pulled the negative 1 out. So, yeah, but the integral.
If I take the derivative of this, it's e to the negative x times negative 1 times negative 1. So it gives you a positive. Okay, good. All right, so we have uv minus the integral. Oh, and we have to evaluate that from 0 to r. Yeah? Because it's part of the integral.
I thought you did have to do that.
No, you have to do it.
Okay, I thought it was part of
Okay,
the-
glad we straightened that out. And then it's u prime times v, right?
Yes.
So we'll change that to a plus.
Well, it's gonna go back to negative.
Is that right? Something doesn't smell right here.
Yeah, that's smart. That's what I was doing. Then you integrate and you get negative e to the negative x.
Okay. That's a minus, right?
Yeah, it's gonna end up turning into a negative.
Ah, I pressed the eraser button.
Because
Press.
if you deal with the negative x and the e, it's gonna be negative e to negative x.
Okay.
Yes. Plus, or no.
No, we have limits now, so, okay. There are a couple ways to approach that one, but
Plug in R.
yeah, let's just plug it in and see what happens. This would be
Can you do that?
0 minus 1. Okay, this is causing trouble.
So if you
It's
evaluate the negative x, you use negative x.
How do I deal with that?
Yeah.
So does that, which one approaches infinity faster? The top or the bottom?
Okay, plug it in. What do we get? Infinity over infinity, right?
But which one approaches it faster?
No.
No.
Infinity over infinity is an indeterminate form.
L'Hopital.
L'Hopital's rule.
No.
Okay, so we're thinking here. One over
Oh my gosh.
Why is it this?
So it doesn't exist.
So 0. 0. 1.
no, because this is now 0,
Yeah, that's what I was saying. 0, 0.
0, 1.
Okay.
So remember your limit techniques, okay? That's the point here. Good?
Yeah.
Okay, they're really not difficult. You just got to use the math you know. Okay, you know all the math.
This is just not everything we've looked
Okay,
at.
turn to page 438
Okay.
really quick.
This involves everything we've looked at right now, doesn't it?
Yeah, for the rest of the way, you're combining derivatives and integrals every day, so you got to keep them straight. There is a theorem there. Theorem 1 that I want to point out to you. The integral from a to infinity of 1 over x to the p. Somebody has proven where this converges and diverges already for you, and where it converges to.
Can we just guess?
How beautiful is that? So, it converges to this number if p is greater than 1. So if you know the formula, you don't even have to do the integral. Okay? And it diverges if p is less than 1. You don't have to know that. Okay, you can just straight do the integral.
What is it for that?
Okay. So we did this one, right? What was p? 3, right? So if p is 3, we know it converges to whatever this a value is. In our case, it was 2. 2 to the negative 2 over 2, which is 1/8. That's what we got. Okay, so our example we showed for x cubed from 2 to infinity fits this model, of course, because it's a general theorem. Okay, so if you want to memorize it, have fun. If not, you don't need to, because you can just do the calculations. Okay. You don't, okay, I will explain it to you.
I don't even understand.
That's what I'm going to show you. This looks like a lot of work. In fact, it is.
And we have 1 day to do it.
You have two, actually.
Okay.
We're going to do some more work here tomorrow. So, yeah, do Thursday. And you have about 2 or 3 minutes. But we'll have a lot more time to work tomorrow. Because if you don't understand this, let me give you an example.
No, I think that the 86 comes.
That's because I'm standing in the way.
Yeah, I was just about to write it down when he stepped in my page. It was like, oh.
All right, so
Is it down?
if you don't understand this, okay, think A is 2. Here's an example. A is 2, P is 3,
Oh.
right? So I'm just going to plug them in. That's the area under that curve. Okay, so it's just an algorithm that gives you the answer if you want it, right? Well,